morning, sir.
Good morning. Good morning, all of you.
Good morning, sir.
Good morning.
Good morning, sir.
Good morning.
Good morning.
Okay, so let's start with the with the mention of the Picard's theorem. In the last class, some of you asked an interesting question that if you keep on changing the domain D, keeping the point x0, y0 always inside the domain, so whether we will always get the same solution. Okay, so that was the question. And the answer is that we will not get same function because domain is constantly changing. So if we change the domain of a function, naturally the function will change. But the thing is that at the point, it will pass through all the solutions will pass through the point x0, y0. So this much we can say from the existence and uniqueness theorem. If the function in the right hand side satisfies the conditions of Picard's theorem, that means f should be continuous in the domain along with its partial derivative with respect to the dependent variable y. Well, so next we will just recall. This is not in the syllabus. This is just for recollection. Okay, ordinary differential equation of first order and first degree. And we can write it in the form mxy dx plus nxy dy. Okay, either we can put it in the form dy dx is equal to fxy, or in differential form it can be written as this. And depending on the method of solutions, first order and first degree ordinary differential equations can be divided into 4 types. So equations solvable by separation of variables. That means we can isolate the x dependent terms as well as y dependent terms from the given differential equation, and in that case simply we will integrate the system and we'll get the result, provided the functions are nice, so that elementary integration is possible. Now next, the homogeneous equation. I will just touch each of the types very briefly because already you know all these things. Homogeneous equation means which can be represented in the form dy dx is equal to f y by x or x by y. Okay, I will come to the examples and exact equations and then linear equations. Okay, so let us discuss one by one. Separation of variables. That means the forms of m and n, which are functions of x and y, are such that we can rearrange the equation and write the equation, differential equation, in the form f1x dx plus f2x dy is equal to, sorry, f2y. It will be f2y. There is a typo. Please note that. So f1x dx and f2y dy. And then simply by integrating the system one can solve it. So let me just correct it. Fy, it will be y, not x. Okay, so some examples are given. I will just show the solution of one of the equations, x squared dy dx plus y is equal to 1. So let's see. X squared dy dx plus y is equal to 1. So this is the differential equation, and we can write it as so what is the equation? Yeah, y equal to 1. Okay, control Z. Yeah, so x squared dy dx, this is equal to 1 minus y. We can represent it like this. Then dy over y, 1 minus y is equal to dx by x squared. So you see, we could separate the variables for the given differential equation. Now you just integrate it, you will get the solution. 1 minus y is equal to integration dx by x square plus c is the arbitrary constant. Now this is equal to minus log mod of 1 minus y, this is equal to minus 1 by x plus c. So this is the solution of the differential equation, which we could separate it in terms of the variables. Okay, we could isolate, or we could separate the variable x as well as y, and we could solve it easily. Next, homogeneous equation. You are well acquainted with this type of equation. So the differential equation, which can be represented in the form dy dx is equal to f of xy, and in this case, if we use the substitution y is equal to vx, we can easily solve it. Okay, you look at the some examples are given. You can look at the first equation, x square y dx minus x cube plus y cube dy. So how we can look at, we can easily check if the terms are polynomial in nature. We can easily look at the total degree of the variables, and then if the degrees of the variables are equal, then we can easily determine that this is a homogeneous equation. Okay, and if they involve other type of functions, then we have to see, we have to represent it in the form, either in the form f x by y or in the form y by x. So let us take the first equation and show you how to solve it. And this is the substitution which will always work. Y is equal to vx. X square y. Let's see. X square y dx minus x cube plus y cube dy. This is equal to 0. So you see, we can write it as dy dx is equal to x square y divided by x cube plus y cube. So let us put y equal to vx as I mentioned. So dy dx then can be written as v plus x dv dx. Okay, so then this equation one changes to v plus x dv dx. This is equal to vx cube divided by x cube plus v cube y cube, x cube, sorry. So it turns out that on simplification, we will get x dv dx equal to v by 1 plus v cube minus v. And then, and this is equal to minus v cube, v to the power 4 minus v to the power 4 plus 1 v cube, 1 plus v cube divided by. So next, this will imply dv x. So what was that? X dv dx, no? So x dv dx. So 1 plus v cube divided by v to the power 4 dv plus dx by x. This is equal to 0. So now you see 1 by v to the power 4 plus 1 by v dv plus dx by x. This is nicely integrable. If we integrate it, we'll get
1 by cube into s cube by 3 minus ln y is equal to c.
1 by 3 v cube, right? Plus log, e base log, of course, v plus log x. This is equal to c. And note that while writing the log, we are assuming that the variable v is taking such values for which log is defined. Okay, so log vx you will get. So therefore, this is equal to y by x. So x cube by 3y cube plus log y equal to c. This is the answer. So homogeneous equation, you know how to solve it. Just we have to first identify that whether the given equation is homogeneous or not. Then we have to use this substitution, y is equal to vx. Then we have to write everything in terms of v and x, and we will be able to solve it. Achha, so some of you are trying to. Achha, so today I think there is no problem, no? Hello?
No, no sir,
Okay.
because
So
there
there
are
is problem.
too many problems, sir.
Today is
Huh?
no problem.
Today is also a problem, sir. I had to try many times to join this.
Sir, make
Problem
something,
is there.
sir, make something new settings that anybody cannot start any meeting except you, sir. Do something needful. Otherwise, there will be problem in
Yeah,
every.
so today also
they
some of you
join
started the meeting, and then I had to stop those meetings, and then I started of my own.
Sir, if we join the class 2-3
Another
minutes, they
meeting
go.
is started, sir, in the
Yes,
team.
sir.
After that, it will.
Wait. Then
the
do some
link is
settings, sir, so
redirected
that
to
otherwise
other.
cannot start meeting. Do some settings, sir, so that otherwise other cannot start meeting. Only you can start.
Yeah, that's what I have written to the admin. So that is the admin option. So I cannot do from my end. So I have to now stress on that.
Okay, sir. Because sir, we have missed the last 2 or 3 classes for that reason.
Yeah, so
Yes,
this
sir.
is technical difficulty. Okay, so let us continue this thing. Homogeneous, you know how to solve it, and then exact equation. Exact equation means the given differential equation of the form m dx plus n dy equal to 0. If we are able to express it in the form du is equal to 0, where u is a function of x and y, where u is a function of x and y. Okay, so if we write the entire thing in this form du is equal to 0, then integrating we will get u is equal to c. But there are conditions. So any equation cannot be exact in nature. So for that, for a differential equation of the mentioned form, if it has to be exact, then del m del y should be equal to del n del x. So this is the condition. And if this condition is satisfied, then the differential equation is exact, and we must be able to write it in the form du is equal to 0. And if it is not exact, then also in some cases we can multiply the differential equation with an appropriate factor, which is called integrating factor, integrating factor, such that the resulting equation becomes exact. That means del y of mu m is equal to, mu is the integrating factor, is a function of x, and this is equal del y of mu m is equal to del x is equal to mu n. Okay, so in many cases, integrating factors will exist, and I will not go into the detail because this is not in the syllabus, but in some cases, simply by inspection, mere inspection, we can convert the given ordinary differential equation into exact form, and for that these differential relations will come in handy. For example, x dy plus y dx is equal to d of xy. X dy plus y dx is equal to d of xy. And then number 2, x dy minus y dx by x square is equal to d of y by x. And instead of x square, if we have in the denominator y square, then this is equal to minus d of x by y. Yeah, so similarly, these two differentials, x dy minus y dx by xy is equal to minus log y by x. So these are basically, these will come using the division and multiplication rules of differentiation. And similarly, x dy minus y dx divided by x square plus y square is equal to d of tan inverse y by x. So if we use these differential relations, then often simply by inspection we can convert a differential equation to an exact differential equation. Okay, so here some of the examples. In the first case, let's see how we can convert it to an exact differential equation using the differential relations. So equation number 1, 1 minus x squared dy dx minus 2xy. Okay. 1 minus x square 1 minus x square dy dx minus 2xy is equal to x minus x square. So this is the differential equation. So let us write it in the form 1 minus x square dy minus 2xy dx equal to x minus x square dx. You look at the right hand side, this is integrable. Only x is involved. Polynomials of x is involved. And also we can write dy minus x square dy minus 2xy dx equal to x minus x square dx. Okay.
Sir, y into 1 minus x square is equal to x square by 2 minus s cube by 3 plus c.
Yeah. Let's complete. So please don't unmute yourself. So keep it. So remain muted. Okay. Otherwise, it will be difficult. Dy minus this part you can write x square dy plus 2xy dx. This is equal to x minus x square dx. And this is equal to dy. This term we don't have any problem if we integrate. Then let us see that x square y d of x square dx. Okay. So now everything is perfect differential. So let us now integrate and plus add one additive arbitrary constant. Y is equal to d of x square y is equal to x square y to x square by 2 minus x cube by 3 plus c. This is the solution of the differential equation. So you see these two terms we have arranged in such a way that we could write it as a differential of some function. And upon integration, it gives x square plus x square y. And other terms are already integrable. So therefore, this is one of the tricks. And next problem, x dx plus y dy. So this problem try to solve. Second problem.
D of xy plus d of tan inverse y by x.
Y by x. Acha.
Yes, d of tan inverse y by x, sir.
Let's see. So this term we have to think little bit. The last term and first two terms are integrable. X dx plus y dx. So
D of
readily we
xy.
can see this. Okay. So just x dx plus y dy plus x dy minus y dx, right? X dy minus y dx divided by x square plus y square equal to 0. So this
Numerator and
is
denominator square.
so this is d of x square plus y square, first two terms, plus you do one thing, x dy minus y dx divided by x square, numerator, and denominator also 1 plus y by x whole square. If we divide by x square, divide numerator as well as denominator by x square, you will get this. Now half d of x square plus y square. So the numerator is d of y by x.
Yes, sir.
Divided by 1 plus y by x whole square equal to 0. Now you can integrate and you can add one additive constant. So this is equal to half x square plus y square. This is like du by or dx by 1 plus x square, du by 1 plus u square, y by x is equal to u. So tan inverse
y by x.
Y by x is equal to c. So this is one of the example by which by simple inspection we can convert it to an exact differential. Well, so now you can solve other problems. Problem number 5, can you just try? Problem number 5. Problem number 5 is xy sin xy plus cos xy. Let's see. Xy sin xy plus cos xy into y dx plus the next term is xy sin xy minus cos xy. Okay, xy sin xy minus cos xy x dx dy, this is equal to 0. So this is the differential equation, given differential equation. So then what we can do, we can take xy sin xy common from the first term of this differential and first term of the second part. So then we will get y dx plus x dy, and this one will couple with this. So we will get plus cos xy y dx minus x dy. This is equal to 0. So this implies what we can do, xy sin xy. This is d of xy, note that. Plus
Yes.
cos xy y dx minus x dy, this is equal to 0. So this part we have to arrange a little bit. So what we can do, we can just arrange the equation in this way. Cos xy d xy, this is integrable, and divide the entire equation by xy. Xy cos xy basically. Then y dx minus x dy divided by xy. This is equal to 0. Therefore, this term, if we divide the entire thing by y square, so we will get dy by x by y. And okay, this is sin xy by cos xy dxy plus we can do like this, x dy divided by y square and xy by y square equal to 0. Now you see, it turns out that we get sin xy by cos xy dxy plus d of x by y divided by x by y 0 equal to, okay, so let us equal to 0 was there. Now let us integrate. Everything is integrable. Arbitrary constant is there, minus log cos plus log x by y equal to c. And you can simplify it if you like. And note that definition of xy domains of the differential equation will be such that all the functions involved are defined. For example, y cannot be 0, and cos xy cannot be pi by 2, something like that. Okay, we are not concerned about the domain. So that is why at the outset I mentioned that in most of the cases, yes, we are looking for
the previous page once.
We are looking for formal solutions. We will not check whether this is a true explicit solution or not in most of the cases. Okay, so if we are interested to look at the interested to check whether this is a true explicit solution, then we have to focus on the domains of definition of the differential equation. Otherwise, there will be some problem. In some regions of the domain, some regions of the xy plane, the relevant functions may be undefined. Okay, but that is not the point of concern at this moment for us. But in principle, we can find out the domain of definition of the differential equation. Well, so I think all of you can, using the shortcut methods, that means the differential relations, you can solve all these problems listed over here. Now the last type of equation you have learned previously for first order first degree differential equations, that is linear equations. It can be written in this form: dy dx plus py is equal to q, where pq are the functions of x only. And then it can be shown that particular integrating factor for this differential equation is e to the power integration p dx. So that is the integrating factor. And if you multiply the entire equation with the integrating factor, we'll get this. And now the left hand side can be put in this form, in the differential form: d of y e to the power p dx is equal to q e to the power p dx. Okay, then if you integrate, left hand side will become y e to the power p dx, and this is equal to q, the right hand side function in the right hand side, multiplied by the integrating factor dx plus c, and c is an arbitrary constant. So this you have this type of problems you have solved. This type of form of the differential equation you have solved many problems. Well, so some problems I have listed over here. So I will show you how to solve first and second equations. dy dx plus 4x by x square plus 1y. So let me write the equation. dy dx plus 4x by 1 plus x square y and 1 by x square plus 1 whole cube, I think. Let's see once again. Yeah. Now this is in the form dy dx plus py equal to q. Pq are functions of x. So therefore, what is your integrating factor? That means the function of x by which if we multiply the differential equation, it will become an exact differential equation. So
yes,
from the theory, we know that this is p
s
dx.
square plus 1 ka whole square, sir.
Yes, e to the power p dx, that means 4x by 1 plus x square dx. Then this is equal to e to the power 2 log 1 plus x square, and we can write it as e to the power log 1 plus x square whole square. And e to the power log something is equal to that function, the something. So this is the integrating factor. Okay, so therefore solution of the problem, we can directly write y into 1 plus integrating factor and integration of the right hand side multiplied by the x square whole cube into 1 plus x square whole square dx plus arbitrary constant. So this is equal to dx by 1 plus x square plus c. And therefore, we get the solution as y into 1 plus x square whole square, that is equal to tan inverse x plus c. This is the solution. Now you focus on the second problem. The problem is a bit twisted. So you just look at it and then you tell me if you are able to solve it or not.
So problem number, sir.
Problem number
if
2.
we can divide the entire equation by 1 plus y square, then we can solve it. And then dx by dy. We will be
No, linearity
Linear in X,
will appear, will be reflected if you write the equation in the
As dx by dy.
Yeah.
by dy.
Yeah, you look at the differential equation as a differential equation of x with respect to y. So that means
Yes.
1 plus y square. So let us just check it. 1 plus y square. This is the first term of the differential equation into x minus e to the power minus y tan inverse y plus x minus e to the power tan inverse y dy dx. This is equal to 0.
Sir,
So
minus tan inverse y. E to the power minus tan
Acha,
inverse y.
to the power minus tan inverse y. Okay. Then we will get x. No.
Sir, y into e to
dx
the
by
power
dy.
10
So
inverse y.
multiply the dx by
Inverse y
dy.
plus
Y square dx dy
yes, sir.
equal to x minus
Plus
tan,
x y.
And sir, then again we need to
tan inverse. Sorry, Control Z.
E to the power
E to
Tan
the power
inverse.
minus tan inverse. Yeah, right. So
divided by
now
1 plus
what
y
we
square.
get? Dx dy plus 1 by 1 plus y square x equal to e to the power minus tan inverse y in the right hand side 1 plus y square. So the role of x and y have been changed over here. Okay.
I factor e to the power 10 inverse y.
So e to the power p dx, p is this function now and q is this function. And dy by 1 plus y square, this is equal to e to the power tan inverse y. Therefore, the general solution can be written as x. xy has been changed e to the power tan inverse y. This is equal to integration the function in the right hand side. That is e to the power minus tan inverse y by 1 plus y square. E to the power minus tan inverse y by 1 plus y square into integrating factor e to the power tan inverse y dy plus c. And this is gone and we are left with in the right hand side dy over 1 plus y square plus c. So it turns out on integration you will get e to the power tan inverse y is equal to tan inverse y plus c. So sometimes we have to look at the equation carefully and write the equation in linear form. Then we can apply the standard procedure. Okay, so you try to solve other problems listed over here. I think it should not be difficult for you. So these are the things
divided by x cube, sir. X to the power 2 is divide 1 by x square to
yes.
let t.
Sir, is talking about third question, third problem.
Yes.
So in third we can divide by cos square and put tan y equal to
divided by x square, sir. Divided by x cube. Yes, sir.
You play a little bit. Okay, I will provide you more problems on these things.
Yes, sir.
Okay, so just for exercise. Now this is really in our syllabus. So the things we have discussed so far already you have done in +2 level. Now ordinary.
Sir, I have one question.
Yes.
Sir, how to find that function that will become the exact differential of given means differential equation?
Exact differential equation, you have to express the differential. So standard procedure I am talking about. You have to express the differential equation in this form m dx plus n dy in differential form. This is equal to 0.
Sir,
we can check whether it is an exact equation or not. That is
okay,
when
so then you just take del m del
by del y
equal to del n del x. If that happens, then it is exact. But if it is not exact, still
we can find the integrating factor.
From the exact differential.
No,
how to find u function? Means m dx dy m dx plus n dy can be written as the differential of u, where u is a function of x and y.
For that, use the differential relations. You can arrange it. Okay, if you have this one, okay, so that will give you the confidence that you can arrange the differential equations differentials, okay, in such a way using the relations I have mentioned, the differential relations I have mentioned here, you or other differentials. Okay, so like in the first problem, what differential of x square y, d of x square y we have found. So once you have this relation del m del y is equal to del n del x, then that can be done. Okay, so you can arrange the differentials in such a way that eventually you will reach to the form d of u is equal to 0.
Sir, means in the example, just you have considered, sir, we are finding differential by integrating m with respect to y, partially integrating m with respect to y.
Yeah, that method is there.
Yes, sir.
Okay.
IN is free from
But,
x, sir.
But most of the
Sorry,
problems
that
can be solved without going into that method. That is also there. Just using
sir,
these things, you can handle the problem. Yes,
okay.
please continue.
Can I give you an example means of x square minus 4xy? Can you write on the means?
X square
Minus 4xy
minus 4xy.
minus 2y square dx. Whole dx.
Okay, so let me just x square minus
4xy minus 2y square
2
y square
y
dx
square
whole plus y square minus 4xy minus 2x square dy.
Acha, so how to solve this problem? Acha, first of all, what is your m? M is equal to x square minus 4xy
Minus 2y square.
2x square, and n is equal to y square minus 4xy. Is it exact?
Yes, sir. I think
Okay,
so.
then we have to check it.
Yes, sir. Reject, sir.
Yeah, yes, sir. It is.
Yes, sir,
4y
exact.
and
Exact.
del n del x, that is, let me just do it, minus 4x minus no, what happened?
No, sir, no, sir. It is
You
not
need
exact.
you have to take this one.
Minus 4x minus
Reject,
4.
sir. Sir,
Minus
reject.
4x.
Minus 4x
Sir,
minus 4y
what
will
No.
No, minus 4x minus 4y.
Yes, sir. Reject,
Minus
sir.
4x minus
Exact, sir.
this is 2x square. Okay, no need to change. Minus 4x minus 4y. Yeah, this is exact. Okay, so therefore this gives me the confidence that we must be able to write the equation in this form: du equal to, where du is some function of xy. Let us have a look at it. X square dx minus 4xy dx minus 2y square dx plus y square dx minus 4xy dx minus 2x square dx. So these are the terms. Now we will arrange. This is nice term. And what else? No. So there is some
Sir,
mdx.
y square dy
It will
and
be dy.
2x square dy.
Dy. And this is also dy. Now this is nice, and this one is also nice. Then what we can do? We can minus 4xy dx. This can be clubbed with minus 2x square dy. This term can be arranged, this one and this one, and minus 2y square dx minus 4xy dy. This are taken care of. X square dx, it is already integrable. Y square dy, this is equal to 0. Now you look at this term, these two differentials, that is minus 4xy dx or dy. Oh. Minus 4xy
minus d of 2x square y.
2x common ले लेंगे sir.
Yes. So let me just write this is dx, I think. 2x square dy minus 4xy dy plus 2y square dx plus x square dx plus y square dy equal to 0. That means this can be written as 2x square 2x square y minus d of 2y square x plus d 1/3 you can take x cube plus y cube. Now you can see that this is the entire thing is d 1/3 x cube plus y cube minus 2x square y minus 2xy square equal to 0. So this is your u. And what is the solution? Integrating you will get, if you integrate this, you will get this is equal to c x cube plus y cube minus 2x square y minus 2xy square. This is equal to c. This is the solution. And if it is exact differential equation, you know a priori, if you have the information a priori, if you have the information that del m del y is equal to del n del x, then you can boldly go ahead and express the differentials in this form du is equal to 0, and then you integrate and get the solution in the form u is equal to c. But in other cases where del m del y not equal to del n del x, then there are methods actually how to find the for finding the integrating factors. But I am suggesting that instead of keeping in mind all the rules, okay, all the rules are often not self-explanatory or very simple. You have to calculate several things. So instead differential equation in or to convert the differential equation in exact form. Okay, otherwise you can follow the standard route to check all the conditions one by one and determine the integrating factor, and after multiplying the integrating factor you can find the solution. Okay.
Sir.
Yes, sir.
Okay.
Okay.
So now first order but not of first degree. Hello.
The question that you have solved recently, last question.
Okay. Yeah, some of you mentioned this one. Yeah. What is your question?
The previous slide.
Yes. Okay.
So here, why have you find del m by del y and del n by del x?
To check
Exact
that
or
whether
not?
the given differential equation is exact or not. If it is exact, then we know we don't need to multiply the differential equation by any factor. Simply by rearranging the differentials, we can solve the problem.
Sir,
okay, so this is an advantage actually. If you know. Yes.
Use integration of m ds plus integration of n dy. Very easy, sir.
Yeah, yeah. If you know this, if you know that the given differential equation is exact, then just try to rearrange the differentials. You will get the solution. So this is precisely we have done over here. Next is this. Yeah, this is in our syllabus that ordinary differential equation of first order. That means first order differential will appear, derivative will appear in the differential equation, but not of first degree. That means this is the most general form of such type of equation of degree n. P to the power p is dy dx. Okay, that is used conveniently used in the literature. P is equal to dy dx, and p to the power n plus a1 p to the power n minus 1. P to the power n means derivative raised to the power n. Okay, so, this is not nth order derivative.
So the previous slide.
This one. This one.
The previous slide in which you have solved the question.
Yeah.
Yes, sir. Yes, sir. The previous one.
Achha.
Yes, sir.
Can I move?
Yes, sir.
Okay. So now nth degree, first order nth degree differential equation can be a general form of the first order ordinary differential equation of degree n can be written in this form, where a1, a2, an are the functions of x and y. Now these equations can be solvable for p. That means we can express the given differential equation as a factor, linear factor of p. That means p minus some function of xy. I will discuss with example, and then p minus some function of another function of xy, so on. There will be n factors if it is solvable for p minus some function of xy, and this is equal to 0. If we can do that, it is not possible always, but if we can do that, then we will consider the equations, differential equations of the form p is p minus f1 xy is equal to 0, and if we solve it, we will get a solution of this form g1 xy c1 is equal to 0, and then we will consider the next factor. So so product of n factors is equal to 0. So then we have to individually take the factors and make it equal to 0 and solve the first order differential equations. Okay, and in each case, if we get the solutions like g1 xy c1 equal to 0, g2 xy c2 equal to 0, so on, gn xy cn is equal to 0, then the general solution of the original differential equation can be written in this form. G1 xyc. So note that since it is a first order differential equation, only one arbitrary constant will involve. Instead of writing n arbitrary constants c1, c2, c3, we will just replace c1, c2, c3, cn by c, and we can write the differential equation in this form: g1 xyc, g2 xyc, so on, gn xyc is equal to 0. So therefore we have to deal with the separate factors one by one and find the solution, and eventually we can write the general solution of the original higher degree differential equation. Well, so some examples are there. I will solve 1 and 2, problem number 1 and 2, and then rest of the things I will leave it to you. P square plus 2px minus 3x square equal to 0. P square plus 2px minus 3x square equal to 0 is the differential equation. So this is order 1 equal to 1, degree equal to 2. So this is the degree. Now let us see if we can factorize it. Middle term factor, p square plus 3p
plus cx
minus px minus 3x square equal to 0. This implies p plus 3x into what? What else we will get? P minus x equal to 0. So therefore either p plus 3x equal to 0 or p minus x equal to 0. So p plus 3x equal to 0. This will give us the solution dy dx plus 3x. If we deal with this equation, dy plus 3x dx, this is equal to 0. If we integrate it, we'll get 1 y plus 3 by 2x square plus c1 equal to 0. And on the other hand, if we consider the second factor, we will get dy dx minus x equal to 0. So this implies dy minus x dx, this is equal to 0. On integration, we'll get x square by 2 plus c2 equal to 0. Okay, c1, c2 are arbitrary constants. So therefore, the general solution of the given ODE is x square y plus 3 by 2 x square plus c. Only one arbitrary constant we have to use now. Y plus 3 by 2 x square plus c into y minus x square by 2 plus c equal to 0. So this is how we have to solve the problem. Now you take the next problem. P cube minus x square plus xy plus y square into p square plus x cube y plus x square y square plus x y square into p minus x cube y cube equal to 0. You first check that whether this differential equation can be factored in terms of p or not.
Yes, sir. It can be factorized.
Okay, so what are the factors?
X square, y square, xy.
X is
Okay, so let me just show you. P cube minus x square plus xy plus y square p square plus x square y or x cube y, fourth degree term, x cube y plus x square y square plus x y cube p minus x cube y cube. This is equal to 0. So from here we can do one thing: p cube minus x cube y cube minus x square plus xy plus y square into p square, and from this term we can take xy common. Xy, we will get x square plus xy plus y square into p. This is equal to 0. So this implies p minus xy p square plus pxy y square minus x square plus xy. So please mute yourself into p minus xy equal to 0. So now we have p minus xy into p square plus pxy plus x square y square minus x square p minus xyp minus y square p. This is equal to 0. xyp is cancelled. So we are left with these factors: p minus x square into p minus y square. This is equal to 0. Now we have to take care each of the factors separately and solve the differential equations. Now p minus xy equal to 0. This implies dy dx minus xy equal to 0. So dy by y minus dx, no, x dx, sorry. X dx, this is equal to 0. On integration, we'll get log y minus x square by 2 plus c1 equal to 0. And next, let us consider dy dx equal to x square, second factor. So dy is equal to minus x square dx equal to 0. On integration, we'll get y minus x square by 2 plus c2 equal to 0, and the third factor will give us dy dx plus y square equal to 0.
X cube by 3.
X cube by 3.
Yeah, x cube by 3. Correct. Then minus 1 by y plus x plus c3 equal to 0. This is the equation. Therefore, general solution is log y minus x square by 2 plus c, then y minus x cube by 3 plus c into minus 1 plus 1 by y plus x plus c equal to 0. So this is the procedure by which we can solve the ordinary differential equation of first order but of higher degree, which can be separated, which can be solved for p. Now other problems you can try. So
Sir,
these are not difficult. Yes.
Why product is taken?
Yes. Yes.
Sir,
in the
there is
previous slide,
why product is taken?
Just a minute. This one is this one.
Sir,
yes
this
sir,
all
here
should be
I-
C or C1, C2, C3.
yes sir, that's my question.
So
Which
in
one?
a general solution, the product is taken. Can you tell the reason behind this?
Acha. So if it can be shown that if the individual functions satisfy the product terms actually, then this one will satisfy the original differential equation. For example, you have the differential equation p minus xy into p minus x square. You have this, no? P minus y square equal to 0. Now you have some f1 xyc in place of p. No, control Z. You have this is equal to 0. F2 xy c2, this is equal to 0, and F3 xy c3 equal to 0. So these are the three solutions corresponding to the individual factors. So what is the meaning of this solution? If you, so from this equation you can basically
Three solution.
You can basically derive p minus xy is equal to 0. Okay. So you look at the term. So if you take this, so what is the first equation? Yeah. If you differentiate it, I will get this p minus xy equal to 0. You will get from this differential, from this relation, implicit relation. And from this implicit relation, if you differentiate, you will get dy dx is equal to y square. Sorry, there is some mistake. Did I? This will be equal to this. P minus y square was the factor.
Sir, minus 1 by y minus x minus c, sir.
So minus x.
Wrong, minus x minus
Now,
c3.
from this equation, you can derive p is equal to y square. P is equal to y square. If you just differentiate this, you will get this. Similarly, from this, you will get, if you differentiate, you will get p is equal to x square. Okay. Now, you look at the final form. In the final form, what we have done, we have written the solution in the form f1 xyc f2 xyc and f3 xyc. Now if you differentiate this with respect to x, okay, so if you differentiate this with respect to x by product rule, what we will get? Say first two constant, f1 f2 constant, then df3 dx, or you can have f1 f3 constant df2 dx plus f
F2 F3 del F1 y del
f2
x
f3 df1
by del x.
dx. Now you see from this, either from this and this, always you will get one of the factors equal to 0, because they are the solutions of the differential equations considering the individual factors. So therefore, this will be equal to 0. This will give you 0, and this will also give you 0. So, and eventually you will get this is equal to 0. Okay, so that means the original differential equation is satisfied. The original differential equation is satisfied by this function equal to 0 actually. Okay, if they satisfy the differential equations p minus xy equal to 0, p minus x square equal to 0, p minus y square equal to 0, then this will satisfy the differential equation. This will definitely satisfy the differential equation taken as p minus xy, p minus x square into p minus y square equal to 0. Okay. Because if you differentiate this, so this equal to 0 will appear as one of the terms. So therefore, on differentiation, you will get you will see that this is satisfying the differential equation. This.
Okay,
Are you
sir.
satisfied? You think about it. Then today I think I don't have time, so I will explain it in the next class tomorrow. Once again.
Sir,
Okay.
one thing to say, sir, like regarding the class, today I joined from my mobile device before 9 a.m. I could join it perfectly, but when I tried to join from my laptop, then there was a problem. Like I was directed to another meeting. So can you please convey this problem to the organizer of this meeting? Like I think it
Yeah,
is
yes.
happening
Please.
for quite a
Sir,
while. Few people might have faced this problem. So can you please convey this message to the organizer?